Hey guys, let's get started. So, like I mentioned at the beginning of chapter 7, we're only going to discuss about the most simple type of swaps. The first one is the one that we just gone through, a floating to fixed or a fixed to floating rate. And then the second type of swap, also very popular, is the currency swap. And we're also going to talk only about the most simple version of currency swap. It's basically the fixed to fixed currency swap. In the currency swap, the principal is usually exchanged. Yeah, there's actually a principal exchange in a currency swap at the beginning and also at the end of the life of the swap. So we could have this kind of examples. Suppose we have an example of an agreement for one party, the Barclays, and to pay 4% sterling to the British Petroleum, which is actually, and then they're going to, our counterparty is repaying us back a 3% of some kind of principles. So in the current currency swap, we have to specify what are the two types of currencies. First, it's actually a UK bound to US dollar currency swap. And what are the both of the two sizes? The two sizes will be, they both come from different currency types. So the numbers of their currencies, the numbers of the principles will obviously be different. Here, the US principal is a $15 million US principal. And we also have a 10 million pound UK bound principles. The principal is exchanged at the beginning, and then periodically decide that we have an illustration over here. At the beginning, we have an exchange of the principal. $50 million US dollar is received for the for our British Petroleum. And then at the beginning, they paid a 10 million pound, the UK pound, to the counterparties, which actually is the Barclays. And then periodically, we're going to pay some percentage out of the principals. The exchange is for a 3% dollar and for 4% sterlings. So 3% of the 15 billion US dollar, which is actually a $0.55 million, is an outflow every year on February 1st, 2023, on 24, 25, 26, and 27 for 5 years. The 10 million pound was paid to our counterparty at the beginning, and then periodically, every year, we're going to receive 4% out of this 10 million pound, which is actually a 0.4 million UK pound, every year, and then at the end of our swap, we're going to pay back. British Petroleum is principal of a 15 million US dollar, together with the last swap payments, which is actually a $0.55 million. So that's a negative 15.45 million dollars outflows. And then we're going to get back our 10 million UK pound together with the last swap payment. So it's a 10.4 UK pound at the end of the February 2027. So that's the idea about the currency swap. And then currency swap, unlike the comparative argument, is even more suitable for a currency swap. If you think about some of the taxation regulations in different countries, they may have different regulations. So different countries may have different regulations on different type of currency receipt. It might actually make quite good sense for companies to do currency swap. It could also make sense if you think about a company, an international company making a business at a foreign country. They may have periodically some collection of foreign currencies that they want to exchange it back to their domestic currencies. So currency swap, the type of this here we're introducing is the most basic fixed to fixed currency swaps. And then some of the reasons, it could be their business, their own international business. It could be because of the tax benefits, which is also part of the comparative advantage arguments. That's the reason why some companies like to do currency swaps. Currency swap, comparative advantage. Yeah, I think let's just skip this part. I think the more important part is to lecture you guys how we can do valuations for currency swaps. After this part, we'll talk about the valuation for the fixed for floating swaps. But then during the exam, I'll not examine about it during for the regular sessions, because I'm just providing it as an additional knowledge, something nice to know, a supplementary knowledge to know about. But for valuations for currency swaps, I think it's actually a very important idea to learn about. So let's talk about valuation of currency swaps let's learn about it using examples. The term structure, suppose that we are talking about a currency swap of Japanese yen to US dollars. The term structure of interest rate is flat in both Japan and the US. What does it mean? It means that because when we are talking about valuation, we have to do discounting, you have to discount future cash flows. So it's important to know about what's the suitable discount rate to be. And to make things easy, usually we'll questions that just assume for a flat term structure or a term yield curve. Yeah, nice to meet you. Yeah. Right, so let's continue to learn about valuation about currency swaps. So in both Japan and US, we just assume that yield curve. Basically, it means that whenever you want to discount Japanese yen, no matter for what horizons, you have to discount it using 1.5%. And for US dollar, you have to discount it using 2.5%. So now in this deal, are 10 million US dollars and 12,000 million Japanese yen. Payments are made annually, and 3% is received for yen, 4% is paid in dollars. Swaps will last for 3 more years. Current exchange rate is 110 yen per dollar. So current exchange rate is also very important information for you to do valuations, because that's how you can exchange the NPVs for Japanese yen for the NPVs for the US dollars. So yeah, these are the information that we would like to know. And this is a table about the valuations. Before this, let me just draw this down and I'll show you how we can do valuations for this swap for both two parties. Either you are the yen payers or the yen receivers. So assume that we are we are receiving the Japanese yen and we are paying US dollars. So we are paying US dollars. So at first we're going to get 10 million US dollars, and then we're going to pay out 1,200 million Japanese yen. And then every year we are going to pay out 4% of the US dollars. 4% of the $10 million is negative $4 million every year. Year 1, year 2, blah blah blah. Year 3, blah 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 blah. T, that's the last period. YT minus 1, YT minus 2, blah, 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 negative 4 million, negative 4 million, negative yen 10.4 millions, receiving 3%, that's 3%, 36 million yen, Japanese yen, blah, 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 36 million, 36 million, and again, 1,236 million yen. So this is the cash flow that we are going to see. And this swap has to exist for some time periods. That's the reason why we may have a good reason to calculate its valuation. Like our arguments for the floating four-fixed swaps. At the beginning of the swaps, it's usually negotiated so that both the two parties have both zero net present values. But as time goes on, exchange rate may change, interest rate may change in both two countries. So there may be a positive or negative net present values. So now what we're going to see is there's still 3 more terms. We are going to see there's a payment, Here, there's another payment, and we have 3 more years of payments. We are standing at the time point of 1, t minus 3, 1 year afterwards, 2 year afterwards, 3 year afterwards, and we're trying to come up with an estimation of this valuation. There are actually 2 ways to do valuations. We can actually value it as 2 bounds, and we can calculate the difference between the 2 bounds, or we can calculate the forward exchange rates to come up with the present value of each of the future cash flows. What do I mean? I think it's easier I think the valuation in terms of bound prices is an easier way to understand. So let's try this way, okay? Cash flows on the dollar bounds. We're going to pay 0.4 million in a year, 0.4 million in a year. The answer is yes. We know that these cash outflows, we know the interest rate to do the discounting, so we can calculate their present value. We can calculate the total net present value outflows. At the same time, 36 million yen, we can discount it at 1.5% of the Japanese yen interest rate. 36 million, 1,236 millions. We can also do the discounting. At the end, we have the net present value of our US dollar outflows and also the net present value of the Japanese yen inflows. We also know what is the exchange rate. The exchange rate happens to be 110. That was the good old times. And then we can just calculate the US dollar equivalent of this net present value of Japanese yens that we're receiving, and then minus the US dollar outflows. That's how we are able to calculate the value of this swap. Does that make sense? I can show you guys in the tables. This is page 26. Let me zoom in a little bit. So here, the dollar cash flows 0.4, 0.4, 10.4. The interest rate is 2.5%. That's discounted for 1 year. The 0.4 million US dollar outflow in a year has a present value of an outflow of $0.39 million. Today, the $0.4 million outflow in 2 years has a net present value of this much at present. And the 10.4 million US dollar cash flows outflows in 3 years has a net present value of this much. If we sum up the 3 numbers collectively, all the US dollar payments in the following periods has a collectively net present value of $10.4191 million today. That's what you see over here. We can also do exactly the same for Japanese yen, $36 million inflow. Calculate each of their present values, calculate the net present values, and then come up with a difference by exchanging this Japanese yen back to US dollars and subtracting the net present value of the outflows in terms of US dollars. That's how we can calculate the value of such swap. Everything okay so far? Any questions? Let me show you another way. Like some people, I think most of the people will prefer valuation in terms of bounds, but some people like the idea about valuation in terms of forwards. Do you guys remember in chapter 5, we talk about we can actually calculate forward rates with the information of spot exchange rates and also the interest rate domestically and the foreign interest rates. That is actually the case, and we can actually calculate the forward exchange rates according to the information we have. So again, we're paying out so this is another, so we'll get exactly the same answer at the end, but it's a totally different way of seeing the seeds. So now let's do another way. This is valuation in terms of forwards. We know, once again, in 1 year, there's a 0.4 million US dollar outflow. In 2 years, and this is the outflow in 3 years, inflows in terms of yen, 36 million, 136 million in 3 years. The spot exchange rate is $1 for 110 Japanese yens, or like $0.009091 per yen. You can actually calculate the 1 year forward exchange rate, 2 year forward exchange rate, and 3 year forward exchange rate. What is the purpose of it? So I'll show you guys. Do you guys remember how we do the calculation? It's basically a spot rate multiplied by exponential to the power of domestic interest rate minus foreign interest rate multiplied by to the power of the number of years. In 1 year, the 1 year forward exchange rate should be 0.009182. We can also have a calculation for the 2 year forward exchange rate, 3 year forward exchange rate. What is the purpose? So let's plug these three numbers back here. So we can actually calculate the dollar value of yen cash flows in each of the years. The 36 million Japanese yen dollar inflow in 1 year is equivalent to an inflow of $0.3306 million in terms of US dollars. We can also do the calculation. We have the forward exchange rate, Japanese cash flows into yen cash flows in 2 years, calculate what is the dollar value of the yen cash flows, and also we have the last 1,236 million inflows in 3 years multiplied by the forward exchange rate. You know what is the current value in terms of US dollars of this inflows. Now let's add this thing to this thing. The net cash flow is a negative 0.0694. Basically, that's just this negative 0.4, positive 0.3306. Add this number to this number, add this number to. At the end, we have the net cash flows. And that's not it yet. They are net cash flows in terms of US dollars. And they are still taking place in 1 year, in 2 years, in 3 years. So lastly, we have to calculate their present values. We have to discount it back using the interest rate of US dollars, because they're all now in US dollars. Discount it in terms of US dollars, discount it, add it back. You'll get exactly the same number as we do when we do the valuation in terms of bound prices. You can see we have a negative. This is our dollar value cash outflows in our swap. This is the Japanese yen cash inflows in our swap. This is the forward rate. This is the spot rate multiplied by exponential to the power of domestic rate minus foreign rates multiplied by the number of years. Number of years. So that's how we can do the calculation. And then we can transfer this future Japanese yen cash inflows into dollar value US dollar value cash inflows in 1 year, in 2 years, in 3 years. Now everything is in dollar value, even though they are taking place in some future time periods. We can still line them up at the cash flows, both in US dollar values at the same time. And then lastly, this is the net cash flows happening in 1 year, happening in 2 years, happening in 3 years, all in US dollar values. So let's discount them at 2.5% for 1 year, for 2 years, for 3 years, and then add them up. That's the idea about net present value. You get exactly the same numbers, 0.962787898. And if you round it, you'll get this figure. Does that make sense? Any questions? So basically, you can do things in 2 different fashions. You can first calculate the net present value of all the outflows and the net present value of all the inflows, and then revert them back to the same currencies, like using the spot rates, and then add them up. That's probably the more straightforward idea for you guys. Alternatively, we can also do all the subtractions in the same time periods by coming up with a forecast about the forward exchange rate. That's what we learned in chapter 5. We know the spot interest exchange rate. We know the interest rate in the domestic country. We know the interest rate in the foreign country. So there should be a unique foreign exchange rate at some distant time periods. In 1 year, the exchange rate should be this number. In 2 years, the exchange rate should be this number. In 3 years, the exchange rate should be this number. Change all the yen cash flows into dollar value, and with the dollar value outflows, and then at the end, we can calculate the net present values and then add them up. The two ways are equivalent. You should get exactly the same answer. If you don't, then there's something wrong in your calculation. You can use it as a checking during the exam, or maybe I would directly ask you guys to take one of the routes. If I'm asking you guys to do evaluation for a currency swap. Does that make sense? Any question? Yes. Can you say that? Are you saying that the spot rate is a weighted average of all the future forward exchange rates? Mathematically, it's right, but it doesn't make much sense because, like, usually current spot rate is determined, observable. It's something like people would like to know at first hand, and this, like, forward exchange rates are derived from spot rates. So mathematically, 1 + 3 = 2 multiplied by 2, and you can do all the calculations you like, but it doesn't make much like empirical sense to if you're thinking about what's really happening. Any other question? Okay, I hope you guys enjoyed this part. We're almost the end. We almost reached the end. So yeah, so that's the two most obvious type of swaps we learned. There are also a lot of different type of swaps. We also have, for currency swap, we also have fixed for float or float for float. It's just that we're not going to discuss much about them in this course. In this course, there are also some additional type of different swaps. One that got its name 15 years ago was the CDS, the credit default swap. I think it's worth a while to take some time to discuss about it, but it's actually not a swap. It's just named as a swap, but it's more like a betting against some scenarios. It's more like the insurance. So the reason why people say it's like an insurance is because usually the two parties, it's usually one side that's betting against some financial institutions. The financial institutions is CDS, and then the side that buys the CDS from a financial institution is going to pay. It could be every year, every periods, to bet on the existence of some kind of fixed income assets or existence of a company. It could be like if the company defaults on some of their corporate bonds, then the financial institution that underwrites such CDS will pay the buyers some decent amount of money. If not, then the payer will just continuously pay the payments to the financial institution that issues the CDS. The reason why it's called, the reason why it provides an insurance or provides a security, a idea to the CDS buyer is because suppose that we have a notional principal and we have a CDS spread. The CDS spread is usually the payment. It's usually defined on some kind of principal size and by the percentage of this principal size. So here we have an example where we have 100 million principal with 120 basis points or 1.2 percentage points for a 5-year deal. If there's no default on the targets that the two parties have agreed on, then basically every year the buyer will pay 1.2 million to the financial institutions that underwrite such CDS after 1 year, after 2 years, after 3 years to the financial institutions. However, suppose they are betting on a bond or any kind of reference entities, and the reference entities do like suppose that the reference entity is a bond that has a face value of $100, but at the time when it defaults, the remaining value only has a net worth of 40 cents. Then basically What it means is that the bank, the financial institutions that underwrite such CDS will repay the part that's still missing for the default events. You can think of your CDS buyer, and you also hold this bound. For each $100, for each $1, the bound only remains for 40 cents. So you're paying 60 cents. You're losing 60 for the events that is bound is defaulted. And then this 60% of the value will be multiplied by this 100 million principal. So the financial institution, the underwrite such CDS, pay you a $16 million repayment if such default event really happens. So it basically just it's as if you are buying a bond, and if this bond defaults, the party that issue a CDS to you will make it up back to its original face values. That's the idea. The part you lose, they will repay you back. The CDS, the party that underwrite the CDS will repay you back the part you lose on holding this default reference entity. That's the idea. And if you are interested in the idea about CDS, I think you guys can go to a movie that's called The Big Short. I personally really enjoy it, and I actually enjoy all the books written by Michael Lewis. He's a really good writer. He writes a lot of books about financial markets in a very lively sense. So yeah, a lot of movies are adapted by his book, like The Moneyball, The Big Short. He has a lot of really good stories, and he personally has a lot of practical experience on the street. So that's how he can come up with all these kind of stories, and I really like about it. Every book he wrote about was a masterpiece. That's about CDS, and that's about the part that I will be examining during the regular sessions during the exams. So lastly, I want to talk about valuations of an interest rate swap, the floating for fixed or floating. This is the part that John Ho excluded in this chapter, but it was there like in the previous editions. I think this is a very important idea. So let me just spend some time to talk about it, and then we can call it for a day. So valuation of an interest rate swap is conceptually very similar to valuations of like currency swaps. We can do it in both ways. You can value it as if they were two bonds, or you can value it as a collection of forward rates. The problem is that nowadays, John Ho decided not to talk about how to do valuation of forward rates in chapter 4. That's why I think he decided not to talk about this this part in this chapter. Let me talk about. I'll still talk about it, and you guys will have an idea how why they are very similar to valuation of currency swaps. So again, like I said, you can do the valuation of. So again, at the very beginning of a swap, once again, at the very beginning of a swap, at the very beginning of a forward contract, at the very beginning of a futures contract, everything is priced so that it's a fair deal to both parties, the short side, the long side, the side that's paying fixed, the side that's paying floating. It's a fair deal. The net present value is 0 for everyone. But then as time goes on, things could change, interest rate may change, the macro conditions may change, so the discount rate may change, the suitable forward rate may also change. That's the reason why you can calculate value of holding certain positions. It could be the case that you have a positive net present value. It could also be the case that you have a negative net present value. So suppose that, and as I mentioned, you can value it in two ways. You can imagine that if we are talking about valuation of an interest rate swap, you can imagine there are two bounds. One bound that's paying the fixed, one bound that's paying the floating. If you're the side that's paying floating and receiving fixed, the value of the swap is basically the value or the net present value, the present value of the fixed bound minus the floating bound, and vice versa. Alternatively, it could also be regarded as a series of forward rate agreements. Change some payments from month 3 to month 6, from month 6 to month 9, to 9th month to the 12th month. We can just calculate each of the net present value of these forward rate agreements and then add them. How you can do a valuation of swap. And just like the case of valuation of a currency swap, the two-way will always get you the same answer. If not, then you definitely made some errors during your calculation. Let's talk about valuation in terms of bounds first. This is not so obvious comparing to what we learned in valuation of currency swaps. The reason why is because we don't necessarily, because the time period, the problem is that valuation of a floating bond is not so obvious. If you're standing at the time point where the bond, suppose that we're talking about the floating bond, and the bond has just exactly paid the previous coupon payments, then you know that what is the floating bond worth of? The floating bond should always worth its par value, right? It's always the case because they're going to, the floating bond will yield a floating rate coupon, and then this floating rate coupon should be discounted by the floating rate. So it should always be the case that the floating bond should have a price of exactly its par value at the time period right after one coupon payment. The problem is that we don't necessarily know. Now we know, but it's not necessarily the case that we are standing at the time point where a last coupon payment is just paid. So when we are there to value a floating rate bonds, we need to first look at the time when the next coupon payment will be paid, and after the next coupon payment will be paid, you know that it will worth its par value. So you have to we're standing at the time 0, and we know that the next payment will happen at time t star over here. The next exchange, the floating and the exchange and the fixed rate will be exchanged at t star. You know that right after the floating rate payment, suppose that we are imagining these floating payment and fixed payments are a bundle of a floating bound, the coupon payment of a floating bound and the coupon payment of a fixed rate bound. Then right after the coupon payment of this floating coupon, the floating bound will worth the par. Say if it's $100 face value, then it will worth $100 right after the first coupon payment. And then you can add back that coupon payments because you know that there is some payment at T star together with the face value and the coupon payment. You can discount it back to time 0 to decide what is the value of the floating bound. For the fixed bound, it's usually much easier because you know every single cash flows, you just discount them and then add them back. That's how you can calculate the value of a fixed bound and a floating bound. Let me show you in one example. Suppose that we have a swap and the floating receiver is receiving the LIBOR, 6 months LIBOR, and pays a 3% semi-annually compounded on the principal of $100 million. The remaining life is 15 months. What it means is that you are going to have an exchange in 3 months, in 9 months, and also in 15 months. And we also, the question already tells us what is the LIBOR 0 rate. LIBOR 0 rate are the discount rate you need to use to discount these exchange cash flows. It's 2.8%, 3.2%, and 3.4%. And the 6 months LIBOR on the last payment date was 2.9%. What does this information tell us? It tells us about what is the next floating payments. The six months ago, the 6 months LIBOR rate was 2.9%. So the floating payment for the next payment should be of 2.9%. Divided by 2 because it's semi-annually, it's 1, so it would be 1.45%. So what it means is that you can imagine that the floating bound will have now this is the first one. We're going to do the valuation in terms of bounds. What is the floating bound? What is the value of a floating bound in time 0.25 in 3 months? It should have a value of 101.45. Why was that the case? It's because right after the coupon payment, it will pertain a value of exactly $100, the face value. At the same time, it was mentioned that 6 months ago, the LIBOR rate was 2.9%, and it's semi-annually compounded. So the payment should be half of it. It should be 1.45%. 1.45% of $100 is $1.45. So the floating bound has a value of 101.45 in 3 months. What about the fixed payer? The fixed payer is paying 3%. Half a year is 1.5%. It's paying $1.5 in a year. These are in 3 months. $1.5 in 9 months and $101.5 in 15 months. So when we are doing the valuation in terms of bounds, you have to put back that principles so that it's really like a bound, and that's how the comparison could be fair. If we have these numbers, then it's very simple. We can just, discount factor is just the discount rate. The discount factor is quite obvious. It's just exponential to the power of negative 2.8% multiplied by the number of time periods. We call it discount factor is because we're going to use it as a factor to multiply by the cash flows to get its present values. The discount factor in 9 months is 3.2% multiplied by 3/4 of a time horizon. The discount factor for 15 months horizon is the interest rate 3.4% multiplied by 1.25 of a year. So the net present value of the fixed bound is, you can calculate each of the payments, present value, and then add them up. You got the present value of the fixed bound to be $100.23. At the same time, you know that the floating bound will have a value of 101.45 in 3 months. So you can also discount it using the interest rate in 3 months to get the present value of the floating bound. The difference between the two is actually the value of this swap. Does that make sense? Okay, cool. Yeah, so I think the biggest part that you need to overcome is understand why floating bound has a value of 101.45 over there. Let me just illustrate it once again using the figure. I think things will be much obvious. Any of the future cash flows. The reason why is because no matter what that cash flow is, we don't have to care about it. We only have to worry about its value in 3 months. After that, everything it yields will be incorporated into its value of the $100 at this 3 months horizons. So we know that we are standing at here, 0 in 3 months, in 9 months, in 15 months, and then negative 0.25. 3 months ago, it was announced that the LIBOR was 2.9%. So it basically tells us that the floating bound will have to pay $1.45 or $1 million in this time periods. On the other hand, the fixed payers will be paying 1.5, 1.5, 1.5. That is the swap deal. And then let's assume that both of these payments comes from two really big bounds. That 1.5 is a 3% semi-annually paying $100 base value bound. If that's the case, it's as if we are receiving 100 and 1.5 at the end of the life of the swap. On the other hand, if this is a floating bound, this floating bound, right after it paid this floating coupon payments, it will have exactly the face value that's remaining. That's the reason why we can judge and deduce that the floating bound has a value of 101.45 in 3 months. So what we do is basically discount this 101.5 to present, and then let's also discount the 1.5, 1.5, 101.5 of this fixed income bound to present, and then just compare the two, and you can get the value of this interest rate swap. Does that make sense? Any questions so far? Yes. Floating bound. Because you don't know what the floating rate is, but you know that it will worse the par in 3 months. Yeah. So no matter what that future floating bound payment is, it will be already incorporated in this $100 base value. So we only need to care about its the value at this time periods. Yes.
So the 1.45 is from minus 0.25 months, or it is because only the rest.
Sure. What is 0. That's the 6 months LIBOR rate on the last payment date was 2.9%. It says that this horizon has a 2.9% interest rate.
2.9 should, give 0.25 months.
Yeah, in 3 months, not months, year. So that's 3 months. Yeah, that's right. The 2.9% 6 months LIBOR rate tells us that the floating payer will pay 1.45% of the principal to the fixed payer.
Then why that 1.45 will have discounts to 0? But it's
It will. It should. We add this thing to $100 and then together the 101.45 is counted back to 0. That's how you get the value of the floating bond. So it does discount it does got discounted back to present from 3 months from today to present. This 101.45 is a combination between the $100 base value of a floating bond in 3 months and the $1.45 floating per pound, both happening in 3 months. So add the two, discounted back to present, you got the value of the floating bond.
so these two value 1.145 and 100.74. These two are the present value at 3 months. Right? Or
What do you mean by present value at 3 months? Present value is a value that happening at present. So this is the value. The floating bond has a value of this much in 3 months. It has a present value of this much at present. We discount this number back to present to get this number. Yeah, so this is the present value of the floating bond, present value of the fixed bond. And then the two is the value. The difference between the two is the value of the swap. Let's try another way. Yeah, so I think like the reason why it makes it so difficult is because people really don't understand how we can do the discounting of a floating bond. But we have a different way, and this different way will, some people find it okay, some people like the bound idea. So we can actually do a valuation in terms of a series of forward rates. How do we do so? So first we have to calculate it as the 0 rate at time 2 and the 0 rate in time to calculate it following these formulas. So, and there's one thing that's a little bit bothering is that this formula is suited only for calculations in continuous times. So, wait. So the 3.2% and 2.8% are the LIBOR rates for 3 months and 9 months horizons. We can actually, in 3 months, so now let me just use another graph. We're standing out at this time point 0, 0.25, 0.75, 1.25. This is 3 months, 9 months, 12, 15 months. We know that the interest rate, the 0 rate for this period is 2.8%. We know that the interest rate for this period is 3.2%. So we're asking, what is the forward rate for this period? Can you guys do the calculation? We learned about it, and you know that it's very straightforward. We just follow this formula, and you can calculate what the forward rate from time 3 months from today to 9 months from today. It's calculated as 0.032 multiplied by 0.75 minus 0.028 multiplied by 0.25 divided by 0.5. And you know that this forward rate here is 3.4%, compounded at semi-annual compounding, compounded at continuous compounding. The problem is that when we are going back to calculate what is the real cash flows, we need to calculate it in semi-annual compoundings. So a 3.4% continuous compounded interest rate is equivalent to 3.429% semi-annual compounded interest rates. What is really good about it? It's that now we can forget about adding a notional principal and fake it as if they are bounds. Let's just treat them as cash flows. Know that the fixed cash flows, the fixed payers will be paying $1.5 or 1.5 million. 1.5 million, 1.5 million. We also know that this is determined already. We also know that the floating payment will be paying $1.45 million. The floating payer will be paying this much in 3 months. The problem is that we don't know this too. We don't know what the number this one is. We don't know what the number this one is. But we know that it should be derived from the interest rate in this period and also the interest rate from this period. So we can actually just come up with a guess, a fair guess, a reasonable guess what the interest rate in this period and in this period is. And as we mentioned, you can calculate it and it should be 3.4% continuous for periods from 3 months from today to 9 months from today. If you change it from continuous compounding to semi-annual compounding, it will be 3.429%. Calculate $100 million or $100 multiplied by this rate divided by 2. You can conclude that the floating cash flow, the fair payment for floating cash flow should be 1.71 over here. You can do exactly the same and come up with an estimation about what the floating cash flow should be in 15 months. And then we know how to do the discounting. You have all the interest rate for the discounting. You can first net each of the two, just exactly like what we did in the currency swap, and then discount this net cash flows to present values, add up all the present values, you end up with the value of the swap. And you'll see that exactly, the two should exactly be the same. Why was that? Because we are just basically doing a calculation, evaluation for the exact same thing. It's exactly the same swap. We're just taking different routes. You can value a swap in terms of 2 bounds, one floating, the difference between the value of the floating bound and the fixed bound. Or you can imagine as if we are calculating all those forward rates and then coming up with a good fair guess about what the floating cash flow would be in the following future periods. And then add the two, calculate what is the present value of these net cash flows and add them up. You will exactly find the same answer. They are just like a mirroring image to the valuation of the currency swap. It's just that in currency swaps, in the currency swap that we teach you guys, we are teaching you only the fixed for fixed currency swaps. That makes things much more easier. That makes discounting so much easier. If you want to do a valuation in terms of a floating for fixed bound, then you have to consider about how to do a valuation for those floating cash flows schemes. That's the hard part. You can do it either using a forward rate agreements, or you can use it through the valuation of the floating bounds. Both of the two ways will get you the same answer, the same correct answer, but just you can think about it. These will be extra. This will not be in the regular session during the exams. So don't worry too much about it if you cannot like really satiate about this part. Work on the first few parts, especially on the easy ones. I'll have a lot of like straightforward questions like calculating, exchanging interest rate from different compounding methods, or like things in chapter 5, how do we do pricing for very straightforward like forward or future contracts. These are straightforward things, but they will come for a decent amount, a substantial amount of questions. So those questions, you know that you can get very easily get the marks. So you should at least get all those questions correct. There will be some easy ones, there will be some hard ones, but I think that the hard ones will not be account for more than 30% of the exam. So if you just want to get a reasonably good grade, just focus on the basic questions. And yeah, there will be also a decent amount of true or false questions that I ask you about concepts. So it's also very important to make sure you have a clear mind about all the detailed concepts. That's, yeah, pretty much I have to say about the exam. I will post the regulations for exam afterwards, maybe tonight, maybe tomorrow, about all the things you need to know about. And you guys can spend some time work on the cheat sheet, and I'll be in my office on Thursday afternoon for the office hours. You can just bump up to me and ask any question you like. So that's about it for today. I hope you guys have a great week.